In question 7, the first and second terms of an arithmetic progression are 1 upon cos square and minus tan square upon cos square respectively, where theta is greater than 0 and less than half pi. In part A, we have to show that the common difference is minus 1 upon cos to the power 4 theta. Now, when it's an arithmetic progression, the common difference is given by the difference of two consecutive terms. So in this case, we can take the difference of the second and the first term. So the common difference will be the second term, which is minus tan squared upon cos squared minus the first term, which is 1 upon cos squared. So taking the LCM, this will become minus tan squared minus 1 upon cos squared. Now we know that tan squared is equals to sine squared upon cos squared. So we can first simplify the numerator separately. So the numerator will become, so this in place of tan squared, we can write sine squared upon cos squared minus 1. And we can simplify the numerator by taking the LCM. So this will become minus sine squared minus 1 upon cos squared. Now, once we have simplified the numerator, now we can write it along with the denominator. So that will become minus sine squared minus 1 divided by cos squared. And the denominator is cos squared. So we can write it as divided by cos squared. So over here, we can first change the division sign and write it as multiplied by 1 upon cos squared. So that will be equals to minus sine squared minus 1 upon cos to the power 4 theta. And as we need a 1 in the numerator, as it says minus 1 upon cos to the power 4 theta. So if we take, and this was, and if we had taken the LCM, this should have been a cos squared up here. So just to make a correction, this will be a cos squared up here. So all along this way, this will be not 1 over here. When we take the LCM, this would have multiplied by cos squared. So this would have been cos squared over here and over here as well. So now if we take the negative sign common out over here, so that will become sine squared plus cos squared divided by cos to the power 4. Now as sine squared plus cos squared is 1, so that will become a minus 1 upon cos to the power 4 theta. In part B, it says find the exact value of the 13th term when theta is equals to 1 upon 6 pi. Now we know that the nth term of an arithmetic progression is given by a plus n minus 1 into d. So the first term in this question was given as 1 upon cos squared. So we can write it as 1 upon cos squared theta plus n minus 1. So that will become 13 minus 1 into d, which is 1 upon cos to the power 4 theta. Now to find the 13th term, we know that the value of theta is 1 upon 6 pi. So this will become 1 upon cos of 1 upon 6 pi whole squared plus 12. And in the denominator, we have cos to the power 4 theta. So cos to the power 4 will become, so this is theta is 1 upon 6 pi. So this will become cos of 1 upon 6 pi to the power 4. Now to simplify this, we know that if we substitute cos of 1 upon 6 pi in the calculator, and we'll make sure that the calculator is in radian mode. So cos of 1 upon 6 pi is equals to square root of 3 upon 2. So when we have square root of 3 upon 2, if it is a whole squared over here, as we have over here cos of 1 upon 6 pi whole squared, so that will become 3 upon 4. So over here in the denominator, that will be 1 divided by 3 upon 4. And if we have to the power 4, so we can whole square 3 upon 4 again. So if we whole square 3 upon 4, as it is power 4 over here, so that will become 9 upon 16. Now, once we have the values of cos to the power 4 and just one correction over here, this was with a negative sign over here. So the common difference was with the negative sign over here, so that we'll have a negative sign with 12 over here. So this will become a minus over here, and 12 divided by 9 upon 16. Now we can simplify it and write it as, so the 13th term will be, over here the 4 will go into the numerator, so that will become 4 upon 3 minus the 16 will go into the numerator, and that will become 12 into 16 divided by 9. We can simplify it with 3, so 3 times, 3 4 times. So the 13th term will be equals to 4 upon 3 minus, and this will become 64 upon 3. Taking the LCM over here, so or as 3 is already the common denominator, so 4 minus 64 is minus 60 divided by 3. So the 13th term will be equals to negative 20.